Hello students, good evening. Today we are going to discuss about conversion of acids to alkane. In that already we have discussed two methods. Let us just take a brief recap of what we have discussed earlier. Okay, we have seen what are alkanes. In that we have seen conversion of alkenes to alkanes. In that four methods we have seen Sabatier-Sandrens reaction and Wilkinson catalyst, diimide reaction, reductive hydroboration. After that we have seen stereochemistry of hydrogenation to alkenes. After that we have seen conversion of acids to alkanes. In that three methods there is first one is NaOH that is a decarboxylating reaction, and the second one is Kolb's electrolysis. In the last video we have discussed about Kolb's electrolysis. Today we are going to discuss about red phosphorus plus Hi. Okay, let us see how red phosphorus plus Hi will convert this acid group to alkane. Okay, red phosphorus plus Hi, and temperature, heat is needed to do this reaction. Okay, for different molecules there will be different temperature. Okay, conversion of acid to alkanes. Okay, let's see. In the last classes we have seen two methods of conversion of acids to alkanes. For example, CH3 CH2 COOH. In that we have seen three methods, right? First one is NaOH plus CaO. Okay. Second one is Kolb's electrolysis. Third one is red phosphorus plus Hi. Today we are going to discuss about this reaction. As we know, NaOH plus CaO, it's a decarboxylating reaction and the product is alkane CH3CH3. Okay. In the Kolb's electrolysis, as in the last class we have seen, it's a free radical mechanism and the product is CH3 CH2 CH2 CH3. Okay, in the red phosphorus plus Hi, what's the product? Today I'm gonna discuss about the mechanism, how it converts from acids to alkanes. Everything we are gonna discuss. I'm just write how it converts to alkanes: CH3 CH2 CH3. Okay, see here, from acids to alkanes we have discussed three methods. See, NaOH CaO, Kolb's electrolysis, red phosphorus plus Hi. In all these three methods the product is acid, the substrate is acid, but the product is alkane. But how many number of chains? Here 2, here 4, here 3. Okay, let's see red phosphorus plus Hi. Red phosphorus plus Hi, it's a very strong reducing reagent. Okay, it's a very strong reducing reagent. It can convert all oxygen functional groups to hydrocarbon groups. Okay, it can convert all oxygen groups to hydrocarbon group. For example, CH3 C double bond OH. Just now we have seen the product, right? CH3 CH3. Same, red phosphorus plus Hi in the presence of heat. Alcohol. Red phosphorus Hi in the presence of heat. What is the product? CH3 CH3. And if you take a ketone, what's the product? Propane. That is, it can convert all these molecules to alkanes. Some more molecules I can say, like alkyl halide, isocyanide, cyanide group, nitrile group, aryl halide, and ester, alcohol, aldehyde, ketone, alkane, alkene, amide, and see, all these functional groups are converted to alkanes in the presence of red phosphorus plus Hi. Okay, red phosphorus plus Hi, and heat is required for this reaction. Okay, you understand now how much strong reducing reagent is this? This can convert all the functional groups to alkanes. Okay, now we will see the mechanism behind it and what is the use of this red phosphorus. Okay, let's see the mechanism. You have seen, right, all the three methods, NaOH, CaO and HIO, red phosphorus, Kolb's electrolysis, all these three are giving different products. Product is alkane, but the number of carbon chain is different. Okay, let's see the mechanism in red phosphorus over Hi. CS3 C double bond O OH, red phosphorus plus Hi, heat is required, the product is CS3 CS3. Okay, alkene. Let's see the mechanism. If you see here, this phosphorus plus Hi, what happens? Pi3 and nascent hydrogen are produced here. Which hydrogen? Nascent hydrogen is produced here. This nascent hydrogen is very reactive. Okay, this nascent hydrogen is very reactive. What happens? It will just break this molecule and add H over here, and the product is CS3 CH double bond O. Okay, plus H2O. In the presence of water molecule, it came out. In the next step, what happens? Again this nascent hydrogen will attack. Okay, break these two bonds, add H. Okay, let's see now. CS3, just break here one bond, you will get somewhat idea. Okay, break one bond, add H here. CH3 CH2OH. Okay, you understand, right? I just break one bond and added H over here and H to the oxygen. Okay, again in the next step what happens? Again the nascent hydrogen is added and the product is active, as you can see upside. This one will come out as a water molecule. Okay, before forming this Pi3, one thing I want to say, before forming this Pi3, I2 is formed over here. Okay, in the product before forming this Pi3, I2 is formed. What happens? As we can see here, red phosphorus is present, right? If we don't take red phosphorus, what's the reaction? This alkane is present, right? This alkane will react with this halogen. As you can see in the further classes, we will discuss about free radical halogenation. In that, what happened? You know, alkyl halide product is formed here. Okay, for not getting this product, we will add phosphorus. Which phosphorus? Red phosphorus. What happens? It will form as a Pi3 and we can avoid this reaction. Okay, so that we can get alkene. Okay, this is about red phosphorus plus Hi. This is a very strong reducing reagent, you have to know, and we have seen all the three products, what is Kolb's electrolysis, what is NaOH, CaO, and how the product is formed in the red phosphorus plus Hi. Okay, I will write one more example and I will end this session. For example, aldehyde. How it converts? Red phosphorus plus Hi. Okay, break these bonds, H. What happens? CH3 plus H2O plus I2. Okay, plus I2. This is I2. Okay, to avoid this alkane and halogen reaction, we are taking red phosphorus. Okay, you understand, right? Why we are taking red phosphorus? This red phosphorus will take this halogen and it will form Pi3 and we will get the alkane product over here. Okay, this is about red phosphorus plus Hi reaction. In the next class, we are going to study about conversion of alkyl halides to alkanes. In that we will gonna see what is Urge reaction, what is fitting reaction, what is Urge fitting reaction, what is Ullmann, what is Franklin, how this alkyl halide are converted to alkane in the presence of metal or acid, metal or base, metal or